Hey guys, this is Jason Matthew from Trinidad and Tobago, and today we're going to be talking a little bit about pyruvate dehydrogenase and alpha ketoglutarate dehydrogenase. We're going to be looking at it from a level 1 biochemistry perspective. So here's the reaction that pyruvate dehydrogenase will catalyze. So we are converting pyruvate to acetyl-CoA plus carbon dioxide. Now this is commonly called the link reaction because you are linking pyruvate that was produced from glycolysis to the TCA cycle. So pyruvate can't enter the TCA cycle directly. It is first converted to acetyl-CoA, and then that acetyl-CoA will react with oxaloacetate to form citrate. So we are linking both glycolysis and the TCA cycle together. Now pyruvate dehydrogenase complex, it's an enzyme that uses 5 cofactors, and the cofactors are as follows: coenzyme A, NAD+, TPP, lipoate, and FAD. Now you can see here there is coenzyme A, and then you see -SH, and you might think that means that this is coenzyme A with a sulfur hydro group attached to it. That would be incorrect. This whole thing here is coenzyme A. Yeah? They just put -SH to emphasize that the sulfur hydro groups is where the reactive or the functional group of coenzyme A. But this whole thing here is coenzyme A. Now pyruvate dehydrogenase is found in the mitochondrial matrix. So this is the link reaction. It's called an oxidative decarboxylation reaction. That's the type of reaction taking place. Now you might ask, well, why is it called that? Well, first of all, decarboxylation part is straightforward. If you look here, pyruvate has 3 carbons. 1, 2, 3. Then when you look at the products, the acetyl group, so you convert pyruvate to acetyl group, it only has 2 carbons. So it means that you're going to lose a carbon. And when we lose a carbon, we lose it as carbon dioxide. So that's the decarboxylation part. Now, the oxidative part, well, you got to bear with me. For oxidation now, you're looking at in respect to the substrate, which in this case is pyruvate. Now, as you can see, one of the cofactors is NAD+, and NAD+ is going to NADH. That means that it has to gain electrons, and NAD+, because it's gaining electrons from pyruvate. So it means that pyruvate, the substrate, is losing electrons. Pyruvate is being oxidized. So with respect to the substrate in this reaction, pyruvate is being oxidized plus it's being decarboxylated. Hence, we say that the type of reaction is an oxidative decarboxylation. Now let's look at another enzyme, alpha ketoglutarate dehydrogenase complex. Now the alpha ketoglutarate dehydrogenase complex is one of the 8 enzymes found in the TCA cycle. Other names you might see the TCA cycle under would be Krebs cycle or the citric acid cycle. So alpha ketoglutarate dehydrogenase complex is one of those 8 enzymes. It is an enzyme that is found also in the mitochondrial matrix. Now this enzyme and the enzyme before pyruvate dehydrogenase, they have very similar enzyme mechanisms, and because of that they share the same 5 cofactors. So you'll see that the 5 cofactors for alpha ketoglutarate dehydrogenase is coenzyme A, NAD+, TPP, lipoate, and FAD. And alpha ketoglutarate dehydrogenase complex is converting alpha ketoglutarate to succinyl-CoA plus carbon dioxide plus NADH. This reaction, as you may have figured out by now, because it's the same type of reaction as the pyruvate dehydrogenase complex, it means that this reaction is also oxidative decarboxylation. Right? Same kind of mechanism. The alpha ketoglutarate is getting shorter by 1 carbon, so they're going to lose that carbon as carbon dioxide. And NAD+ is gaining electrons from the alpha ketoglutarate to become NADH. So therefore the alpha ketoglutarate, which is the substrate in this case, is being oxidized. So that's why we say it's an oxidative decarboxylation. Another thing I want to point out with the 2 reactions is that, as you can see, there's just one solid arrow, meaning that this is a reaction that goes only in one direction. It's irreversible. So let's go back. You'll also see that there's one solid arrow, meaning that the reaction is non-reversible. So both the PDH and as well as the alpha ketoglutarate dehydrogenase enzyme complex, their reactions are irreversible under physiological conditions. Alright, now it's very important to remember the 5 cofactors for the exam. So people have come up with some interesting ways, like they could use tender, loving care for Nancy, or you could even condense this even further and say TLC for Nancy, where the letters that are highlighted will stand for the 5 cofactors for both pyruvate dehydrogenase as well as alpha ketoglutarate dehydrogenase. So that will be TPP, lipoate. Now TPP, you might see in some textbooks they write out the full name, which is thiamine pyrophosphate. You might see in some textbooks they say lipoate, or they might say lipoic acid. I remember I told you in some books they will put coenzyme A just like that, or they might emphasize -SH. It is same coenzyme A, FAD and NAD+. So these are the 5 cofactors that you have to remember, that are the same 5 cofactors for both the pyruvate dehydrogenase complex as well as the alpha ketoglutarate dehydrogenase complex. So once again guys, I ask you please like, comment, subscribe. Thanks for listening. Talk to you soon. Bye.